Hey, it's me again. Welcome back to Algebra 2, 6.9 notes today for complex numbers. So, like we discussed in class, the complex numbers sits on top of the real numbers. So within the real numbers, you have your whole numbers and your counting numbers, or your natural numbers. You have your rationals and your irrationals, and then on top of that would be your real numbers that kind of umbrella over all of them. And then now we have on top of that, we have complex numbers, which are going to include the real numbers and the imaginary numbers. So if you take a look at what I wrote down here, it says a plus bi right here. So this one has a real portion and an imaginary portion, all right, where the a and b are both real numbers and the I is the imaginary portion. All right, so for example, you could have something that looked like, 3, whoops, wrong color, 3 plus 2i. So the a and the b are real numbers, but the I makes this portion right here the imaginary portion of the complex number. So we're going to do some operations with these, and these work exactly the same way they would if they were an x, if they were a variable. So number one says, find each of the following sums and differences. So when you have a plus sign, basically you can just remove your parentheses. So you're going to get negative 2 plus 7i plus 6 plus 2i. Just take away the parentheses. Now, if you want to use the commutative property, you can move things around a little bit. So I'm going to put my real portion out front, and then I'm going to put my imaginary portion in the back, and then simply combine like terms. So negative 2 plus 6 is 4. 7i plus 2i is 9i. So that's how you add complex numbers. So we're going to do the same thing in b because we're still adding them. So the first thing I'm going to do is remove the parentheses. So it's 8 plus 4i plus 12 minus I. Let's just rearrange a little bit. 8 plus 12 plus 4i minus I. It just keeps things a little bit clearer. You might not have to do that. You might just want to circle them. And remember when we did like terms, sometimes we did this one, and then we did different shapes to kind of separate our like terms. But if you do it like this, now you can just combine these two to 20, and you can combine these two to plus 3i. Now, when you have a subtraction sign there, it's pretty much the same thing, but just make sure you distribute the negative sign as you take away the parentheses. So this becomes 5 plus 3i, nothing changing here. Then this right here, this 2 is positive, and this 7i is negative. Think about it like a negative 7i. So we change the signs to negative 2 plus 7i. Again, we're going to let's say recommute. So 5 minus 2, and then we have 3i plus 7i. So these two become 3. These two become plus 10i. Same thing with d. So d, we have minus 3 plus 5i. Now this becomes negative. Negative is a positive 8. A negative times a positive is a negative 2i. So I'm going to get positive 5 plus 3i. Okay, so exercise 2 is pretty much asking the same thing because it's saying which of the following represents the sum of 6 plus 2i and negative 8 minus 5i. Now, if you're doing sum, another way that you can do these is you can actually just line up your like terms. Because we're simply adding them, nothing needs to be changed. So we're going to get negative 2 minus 3i. Here the answer is right there. So adding and subtracting complex numbers is straightforward because the process is similar to combining algebraic expressions that have like terms, like we were talking about. The complex numbers are closed under addition and subtraction. So for example, when you add or subtract two complex numbers, the result is also a complex number. All right? Well, is multiplication closed? So find the following products. So this we're going to do exactly the same way we would do a binomial. So for example, if I told you to multiply x plus 2 times x minus 5, you would just use FOIL or the box method or whatever method that you would like. I mean, generally, I think most of you are pretty comfortable with using first, outside, inside, last to multiply these together. And if you do that, we can set it up right away um, in like terms, with like terms. So 7 times 3, 21. 3 times 2i plus 6i. 5i times 7 is positive 35i. I'm just combining the like terms here. And positive 5i times a positive 2 is a positive 10i squared. So I get 21 plus 41i. Now be careful here. Plus 10i squared is equal to negative 1. So we have to take this part. So here's our 4i. So we have to take this piece and this piece and combine like terms. So this becomes, let's say, 21 plus 41i minus 10. You can do the extra step. You know, just multiply the 10 times the negative 1, and now you can combine the like terms. So we get 11 plus 41i. Take as many steps as you need. Don't feel like you have to do things exactly the same way that I do them. If I'm skipping a step, and that's why I'm really trying not to, or maybe I'm not skipping a step and you want to. So just remind yourselves that you don't have to do things exactly like the next person. All right, so let's go on to B. Negative 2 times 3 is negative 6. Negative 2 times negative 2i is positive 4i. Positive 6i times 3 is positive 18i. And positive 6 times a negative 2, do the numbers first, your coefficients first. Positive 6 times negative 2 is negative 12, and then I times I is I squared. So negative 6 here, positive 22i here, and then negative 12 times the negative 1, because I squared again is negative 1. So now we have to realize that, now, again, let's not skip this step. Let's say negative 6. Why don't we even commute the two numbers? So we say negative 6 plus 12, because this turns out to be a positive 12, plus 22i, whatever works for you. And now simply let's add these two together. So we get positive 6 plus 22i to be our final answer. How are we feeling? I sure wish I could hear you. Okay, yell louder. Maybe I can hear you. No, maybe not. All right, so let's do the last one. Or maybe you want to try the last one. Why don't you try the last one on your own, and let's see if we come up with the right answer. All right? So pause the video, try that, and come back. Okay, ready for the solution? There we go. So how did you do? Hopefully you're telling me you did great. All right, we have two more problems to do. So when you're ready, why don't you pause, write down what you need to, and then meet me at exercise 4. Okay, so we're just doing the same thing here. We're just simplifying. If I gave you this with x's, you'd say, Mrs. Teets, this is not Algebra 2 work. But because we're using an I, where we have to make that relationship that I squared is equal to negative 1, that's what makes it Algebra 2. So it basically is telling us we have to come up with this A plus BI form. So one step at a time. Let's do our multiplying of our first part right here. So this is what we're doing right here. So this becomes negative 15 plus 5i minus 6i plus 2i squared. So this becomes negative 15 minus 2, right? Because this is 2 times negative 1. So right over here, this becomes 2. I don't want to do that. 2 times negative 1. So that's where that negative 2 comes from. And then 5i plus 6i is negative 1i. And I'm just going to write negative I if that's okay. So this becomes negative 17 minus I. Now I've only done this blue part right here, this part right here. Right here. I haven't done the other part, so why don't we do that in a different color? So now I'm going to do this part. So this part over here becomes 4i times 2, which is 8i, and 4i times positive 3i, which is 12i squared. So this becomes 8i plus 12 times negative 1. So is it okay if I move that real portion out front and make it negative 12? Sorry about that quick interruption. So the negative 12 is going to move out front, and I'm going to put plus the 8i here because we always like to make sure that we're doing things in a plus bi form. All right? So now I have this piece plus, there's a plus sign here, this piece. So we're going to just combine these like terms now. Negative, so let's write it down. Different color here. Negative 17 minus I plus negative 12 plus 8i, and you can stack them with like terms around each other, on top of each other, which is negative 29 plus 7i. I'm hoping that you're thinking this is really easy, because it really is. The only concept you need to know here is that I squared is equal to negative 1. The other skills you should have. Last question, number 5. Oh, right, before you start independent practice. Which of the following products, multiplying, would be purely a real number? So this requires us to actually do the math all together. All right? So if you took a look at each of these, you would have numbers like, let's just do a couple. Let's do this one because I have the room. So this is positive 6 minus 12i minus 2i plus 4i squared. So this becomes 6 minus 4. That's minus 4 becomes minus because that I squared. All right. Plus 10i. So this becomes 2 plus 10i. So this is complex. So that isn't going to be my answer. So you're going to check all of these until you get to number 3. And number 3 is a little bit different because when you do these, you get 25 minus 10i plus 10i minus 4i squared. So this becomes 25. These two cancel. Minus 4 times negative 1. So it becomes 25 plus 4, which is 29. So there's my answer. All right, those two are called conjugates. When they have the same, remember difference of perfect squares? They were conjugates, right? When you had something like x plus 4 and x minus 4, the middle terms dropped out. So the middle terms, which is usually the imaginary portion, drop out. So that makes it completely a real number when we're all said and done. So we can recognize that. We're going to talk about that some more as we get through our independent practice. All right, so until we start that in our next class, always make good choices and be safe. Have a great one.